Yeah, hello, welcome back to another exciting moment in our audio engineering course. Today in this module, we'll be talking about one of the most important tools that we have, which is the one that we use to process audio signals. We call them dynamic processing tools. We'll be talking about these tools. But before we go into it, there is one concept that is necessary for us to understand. We'll be going to that, which is dynamic range. What is dynamic range? How do we affect or process dynamic range? These are the main things that these tools use to actually affect the signal. So we'll be talking about that. Then we go into all these processing tools like compressors, expanders, noise gate, limiter, and the rest. Then we talk about the parameters also that we use to affect these signals. And before we have dynamic range, we have to remind ourselves of signal level and dynamic range. Let's go. Signal level and dynamic range. Now, in music production, because let us use that as a reference, because that is what we work mostly. Dynamic range means the difference between the loudest and the quietest sound. It is measured in decibel. That is one thing we need to know. But when you talk of dynamic range, that range refers to the difference between the loudest part of our signal and the softest or the quietest sound. So we have to look at the difference between the two. And this difference is being measured in decibel. So in a single audio track, dynamic range means the decibel difference between the loudest and quietest moment in an audio file. That is just the definition. So they say if you have a bunch of audio devices like microphone, mixing console, effect processors, power amplifier, and loudspeaker. Understand? So you say that the mic is connected to the mixer, and the output of the mixer is connected to the power amplifier, and the output of the power amplifier is connected to the loudspeaker. Then one of the simplest things that you can do to improve or optimize your audio quality is to look after the gain of the signal flowing through your system, which we call gain stages or structuring. Gain staging or structuring. That is very, very important. And this process is what the dynamic processors affect. So most of the time, we want to make the signal as loud as practically possible. That is always our aim. But there is one constraint, which is the fact that all electronic audio equipment acts a maximum signal level that it can handle before it starts clipping. So that is another need for us to process our signal dynamically. So this process now describes the dynamic range of your equipment, because every equipment has got their own dynamic range, which you know the difference between the noise floor and also the peak before distortion or before clipping. As you can see in this diagram now, you can see there are two things here. We are talking of dynamic range here. This is the noise floor. There are three stages. We have the noise floor, we have the optimal signal level, and we have the distortion level, which is the clipping. So there are two things. One affects the equipment, and also one affects what? The signal that flows through it. So this one that's called dynamic range affects most. These are the equipment dynamic range. That is the equipment dynamic range from the noise floor to the distortion level. That is it. But within that equipment, the dynamic range of signal that passes through is have to deal with from the above the noise floor to the optimum signal level. That is what the optimum signal level, and also the headroom. That is what we got. We are going to be talking about this, and we explain all this in the course of this module. Let's go. So dynamic range, as said before, is the ratio of the loudest undistorted sound. Remember that. Loudest undistorted sound. It can be loud, but not distorted. And it can be loud and also distorted. So your aim is for the loudest undistorted sound to the quieted discernible sound. When you talk of quietest discernible means that it's above the noise floor. That is, it is what? It is easy to perceive. So this is the expressed word in decibel that a system is capable of what? Of producing. So the dynamic range of any recording is defined as the ratio of the loudest peak to the quietest expressed in decibel. Still, so we have to keep on repeating that so that you know the difference, you know what a dynamic range is before you can use dynamic processor to do what? To process it. So for context, the human auditory system has a dynamic range of about 90 dB. That is from the baseline of 0, silence, which is 0 dB sound pressure level, to 90 dB sound pressure level. So a person with a healthy hearing can perceive everything from a whisper, roughly 30 dB SPL, to a jet taking off at 140 dB SPL. So the graph on the right shows, you see this graph, shows the listener's tolerance of our dynamic range in a variety of playback environment. Now, this is the normal level for signals in every situation. If you can see, for this is cinema, you see the noise floor because it's padded, it's very quiet. And you can see the normal level at 0 dB, at 0 dB voltage. That is it. There is a lot of headroom there, the peak, for them to go to. And you can see them now for every, look at the theater, living room, kitchen, bedroom. You can see even our iPod, car, in-flight entertainment. You see, it has a lot of noise because of the engine and everything like that. But when it is being treated by dynamic process, you see that everything now moves up. So it can be perceived. So that is how a dynamic processor will do what will affect the dynamic range of every signal within an environment. That is what we are saying now. Let's go on. So dynamic range, which is the difference between the quietest and loudest and an audio system without distortion, it indicates the amount of volume variations that is dynamic in audio. This is how it has its name, because the system, the audio signal is what? Is dynamic. That is, there is a level, variations in level. That is why it is called a dynamic variation in audio. So the larger the dynamic range, the more contrast you will hear between the quietest and the loudest part. Understanding dynamic range is important for audio production, acoustic and audiology. It affects the clarity and details of how we perceive sound. That is very, very important. And we know about all these things because of this program. As you can see, this is a single signal. This is how we perceive, we view signals in our digital systems, in our computer. This is a waveform. So you can see from here, you see there is a very low level of signal here, which is the quietest system here. And also, you can see the highest level at the top. So between the highest and the point, we call it, that is our dynamic range. That is what we mean by dynamic range in that manner. So dynamic range, which is the ratio of the loudest and distorted sound to the quietest and discernible sound, expressed in decibel, that a system is capable of what? Of producing. We need to keep on reminding ourselves of that. So the dynamic range of any recording is defined as that. That is, we are going to actually get it right. It's defined as the ratio of the loudest peak to the quietest, expressed what? In decibel. So from this area, you can see that we call the difference between these 2 points dynamic range. This is the loudest, up and here, peak, and this is the softest here. So the difference between the softest and the is called what? It's called the dynamic range. So you will know what exactly are you processing. If a signal is not loud enough or is not too loud, you cannot affect it with dynamic. You need to increase the level. But if there is a variation in the signal level from the source and it overshoots your level, try to do what? Try to affect the circuitry of the system. Then you have to process it dynamically. Thank you very much for listening. If you really wanted to know more about our courses and to become a professional audio engineer and certified audio engineer, then call this number on your screen. Thank you very much.